Hey, I'm Josh from Vacuums R Us in Colorado, and today we're going to be working on a Sebo Felix. The customer's reported issue is that the brush roller doesn't spin. The first thing we always do on repair check-in when we get the machine to our bench is we read the work order. We verify what's on the work order. In this case, it's simply customer reported the brush roller doesn't spin. Our front-end associates verified that on check-in. I actually had another technician had already started troubleshooting it, verified that was true, and then they actually kicked it up to me. We're going to go over all of the different various potential failure points that can cause your brush roller not to spin. In this video, I don't know what the issue is on this one yet. I have my suspicions, the common failure points, but I'm going to run you through the whole thing so you can figure it out. Now, caveat to this video is not intended for the average home vacuum cleaner user. This is intended for dealers and authorized service centers. The primary reason for that is that these machines are mostly under warranty. Particularly the black machines, the Onyx collection, which is dealer exclusive. A lot of those machines have decade-long warranties on them. If you're a home user, this is your machine you're about to work on, verify that your warranty is expired before you start working on it. If you start working on the machine and you open the machine, you will void your warranty. If you're under warranty and there's a failure, there's a component failure, and you're covered by warranty, you bring it into a service center, you drop it off, they repair it, order the parts, whatever, there's no charge to you. If you decide that you're going to fix it on your own, the second you turn the screw, your warranty is void. And there's plenty of good reasons for that. I don't want to work on your junk. All right, I don't want to fix your mistakes. I want to just fix what's broken, okay? So we're going to start the troubleshooting process here. The first thing I'm going to do, I'm going to triple, quadruple, duple check to verify there's nothing else going on with this machine. So on these machines, there is the power button right here is also the power light. So that's the actual button. They tend to stick, and frequently I'll have customers bring them in and say, you know, my head's not powering on, and I just push it real hard and it turns on. And in that case, we sometimes will replace this clear piece. Sometimes we'll replace this housing right here that clear piece is in because it tends to stick. That is not the case in this case. So we're gonna go ahead, we're gonna remove the head. There's a button right here, which will allow us to pull the upper body off the machine. Next, we're gonna open it up. Incidentally, this particular machine is actually not under warranty. This is an older Felix. So we're going to pop the top off the hood so we can get into some of the components and do some of the troubleshooting. There's 2 screws in the back, one of which is missing, as it turns out. So we'll need to address that. 1 screw over here, and then we have 1 long screw right here. These 2 screws do not need to come out. Those are short screws, and these 2 screws are holding down the base plate. They do not need to be removed. I'll flip that over. I'll grab and then so the hood is going to go forward like this. I'm going to flip it up and open this right up. There's a couple of common failure points. One of those common failure points is there's a blue micro switch right there, and what that micro switch does, you might be able to hear it on my mic. That micro switch will disengage the brush roll motor when the machine is in an upright position. So when you put the machine in an upright position, this micro switch will disengage the motor. I'm going to go ahead and check continuity on that switch to verify that it's functioning. So anytime we're using a multimeter, we're going to first test to make sure that our wires are all hooked up. All right, so I've got good continuity there. And on this particular micro switch, you can actually test it without removing it. You can get to the contact points there at both ends from right here. So what should happen is when we recline it, I don't know if you can hear my multimeter is beeping. We do have continuity. On recline, you should have power running through, you should have continuity rather running through that switch. And we do. So the micro switch is not the issue in this case. It's not unusual that is an issue, however. So that's a really good place to start. The other place that you can see failure points is there's power running in right here. That power runs through some wires that come through here and then kind of twist out and come into here. This is a relatively stressful spot here. Wires are going back and forth, moving constantly. You know how you vacuum. If this is your vacuum, right? Bang it around, all that. So sometimes those wires will lose continuity. So I'm going to test continuity on those 2 wires. So my wires come down through here. They curve under and kind of around the motor, and then they come into the back of the PCB right here. Now, again, I don't really need to remove anything. I can actually make my contact on the back of the PCB right there. I can see the wires come through the front. All right, so you can see I have two protruding contact points right here. And if you look at the other side of this, you'll see that those contact points are where the power is going into the. So these are the two contact points that we're going to be testing continuity against. On the other side of those contact points, this is where the wires are bolted into that board. And so we're just going to simply we're just going to touch on this side to check our continuity. So what I'm looking for here is I want to make sure that I have power flowing from here to there. So I'm going to touch one of these contact points, and I don't know which goes to which. Okay, so that's my right contact point. My left plug right here is going to my right contact point. And then I'm going to check the right, and I have continuity through there too. So I have continuity through this wire into this board. Now those two things we just tested are actually the two most common failure points on these heads, that micro switch and those wires right there. That's the most common stuff. So you want to test those first. The next thing we're going to check is the power switch right here. Power switches also fail. We need to pop this out to do that. It just slides in. It slides in right here. There's only one way you can get it in. You wiggle it around. You can get it back in there where it goes. There's only one way it can go. So we'll pop it out, and you'll see that you have two contact points on your switch right here. I'm going to touch those, turn it on, and I have continuity going through my switch. So power is also going through my switch. So at this point, we only have two components left that could potentially be causing this fault. We have the motor itself, and we have the board. Up until here, these are the most common failure points. The motors very rarely fail, and the PCBs actually very rarely fail as well. So the next thing I'm going to do, I want to give a disclaimer here. If you're not comfortable doing this, do not try it. Don't try this at home, kids, and I'm not liable for you potentially electrocuting yourself. We're going to be dealing with bare wires here to test this motor. I'm going to first remove the belt so that the brush roll does not spin when the motor engages. If the motor does work, it will engage, and so I want to remove the belt before I do this. So essentially what we're going to do is we're going to be putting live 120 volts directly to the motor. So we're going to have what most people call suicide cables. All right, so if my disclaimer wasn't clear enough, I think the term of the tool that we're going to use should really help to clarify what we're about to do. So when using suicide cables, again, at your own risk, I am not liable. This right here is the plug that feeds power directly into the motor, right? So I'm going to hook one side of my cable up to one side. Yep, there we go. So when using suicide cables, you'll verify that you don't have anything touching, and then plug in briefly. And we hear our motor spinning. So now we verified that the motor is good. The only possible remaining component on this right now is the board. So the board is the failure point. There's no way that I know of to test the board itself. So I just test everything that is around the board. And if the board is the last thing, then I know that the board has failed. So I'm going to go ahead, I'm going to order this board and get the board in. As far as installing the board, it's really simple. You might consider taking a picture of it before you do this, but I think there's actually only one way to plug these things in. So right here is where your power is plugged in. Your power switch plugs into this side. I'm going to remove these two cords here. One is the motor that goes directly to the motor. This is actually your micro switch assembly. And then the board is going to pop out. And then we're going to see the inbound power right here, which we had tested. That's the wire we tested. There's little tiny Phillips heads. Those wires go in right there. And there's little tiny Phillips heads that hold those in. I'm going to go ahead and remove those. All right, so now I've got the board out. I'll pop the power switch, which again, we also verified is good. I'll pop the board out. You know, a lot of times on these boards, you can visually inspect them and you can see something popped or burned. which further validates what you already know, that the board is defective. I don't see anything in this case to indicate that, but again, we've checked continuity, powers flowing through everything, and the motor itself will jump, so we can be relatively positive that this board is the issue. Hopefully this video was helpful. I'm going to put a link below to the diagram, the parts layout and everything, so you can see all the part numbers and everything if you do need to order some parts. Putting it back together, the opposite of what we just did. Overall, you know, relatively easy machines to repair. They're clearly designed to be maintained, to be repaired easily. They've made the same model for a very long time. They spend a lot of time developing it, so they know they get it right the first time, and then they make the same product for a long time. That's super helpful because there's a lot of documentation on how to work on these things. And again, in closing, I remind you, if your machine is under warranty, don't touch it. Just bring it to a dealer. They will take care of the issue. I'm sure, Mr. Engineer, you're perfectly capable of fixing your vacuum cleaner yourself. You're probably not. But if it's under warranty, save yourself the hassle. Just bring it into a service center. But if it's not, it's already broken. What are you going to do? Break it again? Give it a shot.